Hello guys, in this video we will see how you can use the excellent AI navigation package of Unity to have NPCs or cars move through your game world. Although you can script simple movement yourself, using this system can support more complex movements, avoid collisions, and is more flexible if you want to change or add new routes. We will build this AI navigation into the cars of our GTA game. In a previous video, we created the basic gameplay so the player can shoot and walk and drive cars and planes. But the cars were static, and in a real world, the cars will be driving around. So we will define some routes and have the cars drive them automatically. The first thing we need to do is install the navigation package. So go to the package manager and search for nav and install the AI navigation. Now that we've installed the package, you can find some options over here. The AI navigation. We can define some agents and some areas. I've already defined an agent type car, but you can do so yourself by clicking the plus and calling this car and give it some properties. These are the typical properties for a car, so its height and its radius must be known. We can also define an area. There are already some areas defined, like walkable. We can add an area called drivable. And now we can create an empty game object. Let's call it road navmeshes. And inside here we can add a road. Let's call it road 1. And this road has a left and a right side. So create the game object's left side. Now in here we're going to create a mesh for the road. We already have some road parts over here, but I want to create separate meshes to indicate the road that we will be driving. So you could add all of these and create a nav mesh out of it, but in my opinion it's better to have a separate mesh that indicates the path that the cars will drive on. So over here we are going to create a plane. Let's call it road part. And now we are going to shape that plane. I've created a material over here that we can use. So this clearly indicates the part of the road. Now we will add the other parts. Okay, now I've created all road parts. So 5 road parts of the left road and 5 road parts of the right road. And now over here at the parent of these parts we will create a navmesh service, and we will set this to the agent type to car, the default area to drivable, render meshes. We will collect all game objects, but we will assign a layer to these game objects. So go to layer, we'll add layer, and let's create a road 1 left layer, and also road 1 right, and let's assign road 1 left to these, and road 1 right to these. Okay, so now what we can do is over here we have our navmesh service. We can bake it, and then it will include all the objects that we defined here. So we will choose the layer we created for the left navmesh. Now we will bake it, and after that you will see that it's also indicated, because I indicated it myself with material. It was already visible, but if we disable our own material, you can still see that there is a mesh created, the navmesh, and we can do the same for this one. Now that we have our navmeshes, we also need to have something to navigate on it. This is called the navmesh agent. So this can be a person in the case that you have a walkable area, but in our case it will be a car. So I have 5 prefabs over here, and to this prefab you need to add the navmesh agent. We make it of type car in this case, and we can set some properties, and you can over here already see that this kind of represents the agent shape. If you go to the gizmos and we are looking for the navmesh agent and I disable it, you can see that this disappears. So this is our navmesh agent representation. You can see that its shape is not really representing the car, so this will not look very natural in case we have some objects on the road, for example. So we can change the properties over here. We can set the radius a bit bigger and the height a bit lower. So, and we can also change the properties not only of the obstacle avoidance, but also of the agent settings. Okay, so now we have a navmesh agent and our navmesh, but in order for the car to drive, it needs to have a destination. So you need to give the navmesh agent a destination, and we can do that by attaching a script to it. I've already created that script, so I'll just show it to you. So in this script we have a number of waypoints, and we have a current waypoint index, and we just cycle through all the waypoints, and then we set the destination of the agent to the waypoint. So you can see that over here. We also check if it's a valid path, but if we put the waypoints neatly onto the navmesh agent, it should have a valid path, because we have a closed path on the road. So in the car AI script, I can add some waypoints, and I can define them somewhere over here, for example, in my scene. Let's call it waypoint 1, and let's have at least 2. And I can set this waypoint to this location of this guy. So let's copy the position of that guy and set our waypoint to that position. And then the second waypoint we can set, for example, over here. Okay, so now that we have 2 waypoints, we can set those in the car AI script. And then if I run the game, we still have to make this flag AI active true. That's something I built in, because we want the car AI also to disable when the player itself is driving the car. So, but if we enable it, you see that the car is moving, but now it's kind of stuck. That's because there is also a rigid body in here. You can set that to kinematic, and now the navmesh agent will control the car. So it will drive from the destination. And the great thing about this is that it can avoid objects, and it will find its path over the navmesh. But if we observe the car closely, let's make it drive a bit slower so we can inspect it a bit better. Actually, this is not the speed of the car, but this is. So the navmesh speed, you can see that the car is now driving much slower. But we see that one thing is missing. The wheels are not spinning. Of course, the navmesh agent doesn't know about the object that it's a real car and that its wheels should spin when it's moving. So we need to write that in our script as well. So the wheels need to be spinning as soon as the car is moving. We can measure the speed of the navmesh agent, and also we can add the steering to it in the corners. So let's do that now. Go back to the script. Actually, I already implemented that, so I'll just show it to you. Let's remove this return statement over here, and this is how it works. We have a reference to the transforms of the wheels, the front wheels and the back wheels. We have some properties of those wheels that we can change, and as soon as the car is moving, we can check the agent velocity. Then the wheels will start spinning, and the back wheels we can simply rotate by the x-axis. This is the current wheel rotation. This can be 0, but I have one car that has 90 degrees turned wheels, so I need that for this. But this is basically the value. You can check over here. If I go to the car again and select a wheel, you can see that this x-axis is the one that we need to set in order for the wheel to rotate, and the y-axis is the one that we need for the steering. So you can see that over here that for the front wheels we also have a steering angle. If it's the left or the right wheel, it doesn't matter. Both wheels are animated exactly the same, so we can just loop over them over here. And then we can use this to animate the wheels. So if I save this and I try to run the game again, we can now see that the wheels are actually spinning. So it just looks like a real car. I now created this car manually over here, just for the example. But of course we don't want to put all our cars in the scene by hand. We also want them to be automatically replaced if, for example, a car explodes or whatever. So we could even spawn them in the vicinity of the player to keep the performance up. But in order to do so, we need a car spawner. So over here you can see my car spawner script, and it has a child object where we have the car waypoints. So if we take a look at the waypoints, they are on the road. So maybe I can display them like so. If I loop through them, you can see that they all are in the edges of the navmesh agent. You could even leave out some of them. You don't need to add a waypoint in every turn that you make, because the great thing about the navmesh agent is that it can find the path itself. But to make it a bit more smooth, I just and this is so easy road that I just selected all points. And over here we see the same points, but now in the reverse order, because the other part of the road, the cars drive in the opposite direction. And so we have over here the car waypoints root object, and that's also known in the script. It has this root element, reference to it, and it has a selection of all cars that can be spawned, and it will spawn a random car at a random position anywhere on this track. And how that works I will show you now. So we have our road, and we have some cars. Over here you can see the car spawner script. So we have this root object, and in the start of the script we will add the waypoints that are under that root object. We will add them to separate lists, and then we assign one of those lists to the car that's been spawned, and this will be his waypoints. So if you take a look over here, we will put everything over here into a list in the script, and then we assign for example these waypoints to a car if he is spawned, or these waypoints at random. So at this moment all roads are equally busy. If you want to change that, you need to use not only waypoints with a position, but you also need to add a certain weight to every road, and then that road can be more busy than another road. So also now if one road is very small, it will be more busy because the cars will be spawned equally over all the roads. so small roads will have relatively more cars at the moment. So that's just something you could tweak later on. But for now, we will work with this. And so, yeah, a car is spawned at a random one of those waypoint selections. And then we will also select a random index. So we pick just one of these waypoints, and then we look at the second waypoint, the next waypoint, and somewhere between this and this waypoint we will spawn the car. A random value, so it can be in the middle or it can be more to one of the waypoints. So the cars will be distributed quite equally over all of the track. And then we use a random car, one of the cars in the list. So if you add another car to the list, it will also be in the selection. We keep a distance to other cars. So if the distance is too close to an already existing car, we will just try again at another position. You can see that over here we have tries left. There is like 10 tries. You can try 10 times to put a car onto the track. If it really doesn't work after 10 times, the road is probably too busy and can't carry any more cars at the moment anyway. So, and how can we select cars that are nearby? We keep a list of all the cars and their positions, actually all the game objects of cars. Inside this game script, this is like a singleton where I keep some stuff, some values that are important for all the game. So the cars is one of the things that's in there, and we can go through that list, and if we find a car that is closer than the minimum distance, then we know that there is another car nearby, so the no other cars nearby will return false in that case. Okay, let's see what happens if we run the game and if the spawn script is working. Oh, we see over here that there are lots of cars spawned, but that was not the intention. Something went wrong. It's good to see that the game can handle so many cars, but there is obviously something wrong with the car spawning. It's spawning cars without limit. I've now paused the game, so no more cars will be spawned, otherwise the game would probably crash. But we need to find out what's going on. We made a mistake somewhere, and that can happen. So let's take a look at the code. We are using Visual Studio, so we can use that to debug the game. You can set breakpoints and the code will stop at that point when it will be reached. So if we now run the game, we will see when the code hits the instantiate object, that's where the cars are created, and that breakpoint will be hit many times because we saw that many times were created. So now we can see that every time the code is going to the instantiate, but it never reaches the point where the cars are added to the general list. So they are not added to the list that's kept track of how many cars there already are. That code is never reached for some reason. And we can see that that's because over here in the set AI active methods we have this collider enabled set to false, but the collider value is null, and also the rigid body is null. However, they are set over here at the start of the script. They get their values, so the values should be set, but obviously that's not the case now, and therefore the code crashes and never reaches the point where it adds them to the list, where it keeps track of how many cars there are. And so this list is empty, and it will keep continuing adding cars until that list reaches a certain count, but it will never reach that, so it will just keep adding new cars. So we are now checking all the cars if they have this collider and this rigid body, because if they don't, then of course this value will be null. So that's a reason. But as you see over here, all cars that are used have this rigid body and the collider, so that's not a reason why they are null. So let's look further. We can also set a breakpoint in this start method to check when this rigid body will be set, because then it should have a value. But if we now run the game, we see that we reach this start. But before we reach this start method, this fixed update is already called, and in this fixed update we already used the rigid body and the collider. So the problem here is a timing issue, that the fixed update is executed before the start. You can see that the start, it says that it's executed only after the update, but I guess that doesn't count for the fixed update function. The fixed update is similar to the update, but it gets called not by every frame update, but by every 50 times a second. In my case, you can set that in the project settings. But so we can see over here that this set AI active is already executed, and now only now we go into the start and set the rigid body. So that's too late. So what we need to do is fix that. We need to find another way to set the collider and the rigid body, so that it's guaranteed that they will be available at the moment we use that fixed update function. So therefore we have the awake method that's called even before the start, and that's really the first thing when a script is being used. So that will work in this case. So just to remove the setters of the rigid body and the collider from the start to the awake function, and now our value will be available. The game will no longer crash when we use those values to set the AI active, and so the cars will be added to that list, and the spawning will stop after a certain amount of cars. Okay, now let's remove this single car and use the spawn script instead. I've set it to an initial 40 cars. So we can see the cars are driving perfectly on the roads that we defined. There is only one problem, that the guy needs to be able to capture a car, and the cars are moving way too fast now. So he is not able to get into a car. What we need to do is, like in the GTA games, as soon as you get near the car needs to slow down. And we can do that like this. We can adjust the speed based on the player. We just measure the distance to the player, and if the distance is close enough. Then we set the speed, and we never set the speed lower than a certain minimum. And if he gets more far away, we go back to the maximum again, the 20 over here. So we obtain the car in the other position of the player. We obtain him in over here in the awake method, because our player is just a transform that's always in the scene. It's one transform that's called player, so we can easily find that. It's a bit hard coded over here. We could also use a reference, but in this case, because this player object is very static and always there in the GTA, there's always a player, so we can use it like this. You can see the car is slowing down, and if it's slow enough, we are near the car, we can press the F key and we can actually capture the car. Now finally we can remove the renderers, so we don't see them during the game. If you want to bake the navmesh again, because it's now already baked, but if you want to bake it again, you need to enable the renders again, because it looks at the renders when it bakes. It uses render meshes, so otherwise you will not have the navmesh coming back. But if we don't touch it now and we don't bake again, it will stay like this. So what we only need to do now is, if you take a look at our player, as soon as he enters the car, we need to disable that navigation of the navmesh agent, because we want to control the car ourselves with the car controller script. So then we call this method, and it will just disable it and also change the kinematic. We can add the same prefabs that we use to drive on the roads with the navmesh agent, also on the rest of the play field, like static cars. These are the cars that are already there when the game starts. It's like cars that are parked, and because by default the car AI active is disabled, they will not start to move or try to find a path or anything, and we can just enter them like the cars that are on the navmesh services. Over here you can see that we can enter this car, but we can also enter the cars that are driving on the navmesh services. But once we exit these cars, they will no longer be using this car AI script. It will stay disabled, because of course there is nobody else driving in them anymore, so they need to stay on the same position anyway. So actually this set AI active is only making cars active in the spawn script when they want to drive on the services and want to be agents. But actually this part is now never called. Maybe in future there could be some use cases when we want to make them active again. For example, if NPCs would enter the car again, they could become active, but this is not the case right now. This concludes the navmesh tutorial. In future we may extend this to more complex roads, add collision avoiding, have cars stop for traffic lights and so on. But for now, thanks a lot for your attention and see you soon.